Okay, so good afternoon again, all the participants, and good afternoon, Mr. Mandeep Singh ji. So this session will again be engaged by Mr. Mandeep Singh from OptiWave or OptiSystem or HR Universal System. So yesterday we have one great and interactive session, and I hope today we'll also have some another interactive session. So now we are starting, and I am handling the session to Mr. Mandeep. Yes, Mandeep sir, please.
Yes, good afternoon to everyone. So for the second session today, I shall be explaining how we can implement 40 Gbps optical link. So in that form, we shall be proceeding with the 40 GB per second single channel transmission in SMF. SMF, you can say standard mode fiber or single mode fiber. So in that case, what we will be doing in this case is comparing RZ and NRZ modulation format transmission, right? So in this SMF, we will be taking 40 Gbps into account, and apart from it, we will be taking care of loop velocity dispersion, self phase modulation, linear losses, and ASE noise. So I do hope everybody knows about ASE, means amplified spontaneous emission. So this is generally related to the dispersive materials, as you can say for GVD. So in that case, let us start. So in this, so now related to the parameters related to every inch of fiber, you can say we should be precise regarding the beta factors. Beta factors means GVD parameter in the form of frequency, right? The group velocity dispersion, and the bit rate will be set to 40 GB per second, and the next approximation of the kilometers will be done according to the simulations. So let us start with this. So here we will be doing some type of simulations for the post dispersion and pre dispersion. We will compare the data, compare the Q factor, compare the I diagrams, and accordingly we can come to the conclusion like which scheme is better for transmitting 40 Gbps with effect into SMF, right? So this is RZ layout modulation format. So this is a typically similar format what we have discussed yesterday. So in that case, we have used pseudo random bit sequence generator along with RZ pulse generator with a carrier CW laser. Power we have decided here is 4 milliwatt. So this is basically a reference. You can share the reference like it is published in IEEE Photonics Technology Letters in 1997 by Dr. Breuer and Peterman. So this is the first phase when this 40 GB is started for its sources. Now we go for this simulation. The transmission part includes the generic components with power 4 milliwatt, then the channel optical fiber 50 kilometers, then EDFA amplifier, then again optical fiber for 10 kilometers. Here we are using optical fiber 10 kilometers as a dispersion compensation fiber. So this is basically a DCF with proper parameters. We can discuss the parameters used in this also. So at the last, when this channel propagates the signal, the loop control, the number of loops, 10 loops, will multiply it with the length of this fiber. So optical fiber 50 kilometers multiply by 10, 500 kilometers. So we will see how this will behave and provide us a Q factor. And at the detection side, we are using optical Bessel filter before this pin diode, and after that low pass Bessel filter, then at last comparing the results. is NRZ layout modulation format. The change here is the pulse generator. So here, when you will set the global parameters, you should be very careful regarding these parameters. Bitrate, we are setting up for 40, sequence length 128, and samples per bit 128. So those who are operating Optic system right now, in case they want to do these simulations, they can set it right now. Bitrate 40, sequence length 128, sample per bit 128. So now the number of samples, this is a technical configuration which runs for the simulation purpose of these layouts. So the number of samples is equal to sequence length into samples per bit is equal to 16384. Time window 3.2, sampling interval 0.195 picoseconds, sample rate 5.12 terahertz. So these parameters should be fed into global parameters of this layout, and then you can start placing your components. First of all, for RZ generator, what we are using, what I have shown you here, for that we have used a rectangular shape, that is Gaussian. Duty cycle is 0.5 bit, rise time 0.15, fall time 0.25. These all, first of all, let me clear you, these all parameters are taken from the reference papers of IEEE Photonics. So I have mentioned you the name and the letter published in 1997. So you can refer these from the parameters. But there they have simulated for respective 400 and 1200 kilometers. Here we are using less range just for the purpose of getting the results. So for optical fiber, standard optical fiber you can say, or single mode fiber, these are the coefficients: dispersion coefficient, dispersion slope, nonlinear coefficients. So these are the formulas for that. The linear losses, we can mention it point for 0.2 dB. Fiber length, we will taking into account for 50 kilometers. And single mode fiber, the amplifier compensates the linear losses. So that is the reason we are using EDFA there. This is the data for dispersion compensation fiber of 10 kilometers we are using. The formula is the same. Here, for the linear losses, we are using 0.5 dB per kilometer. Fiber length is 10 kilometer DCF. Then we have used the amplifier, so it will compensate the linear losses. Now, what basically do here? So when we simulate it, or when we set the parameters, so we will see how the properties of Bessel optical filter we are using before that pin diode is behaving. So the wavelength 1550 nm and the bandwidth is 4 into bitrate. The cutoff frequency is generic. It is 0.75 of the bitrate you have set up. The ideal periodic amplification, so it is performed by the EDFA component, which also takes ASE noise into account. So we are not taking account of this ASE. The amplifier after SMF has a gain of 10 dB and a noise figure of 6 dB. So these are some of the parameters we need to set. And regarding this compensation, for the dispersion compensation of GVD, we will be using it for pre and post compensation both. And the paper which we are using here is comparison of NRZ and RZ modulation format for 40 GB TDM standard fiber system. So you can go through this reference also. Now in the first part, this will compare the result of RZ and NRZ. So here we are simulating first of all with using RZ scheme. So in that case, a particular duty ratio has been set up and the distance including loops is 500 kilometers. So let us jump to the software, then I will get back to this PPT. These are the parameters I was talking about. So let me first of all tell you how you can set up the parameters. For that, this should be this, because we will be working at 40 GB per second bitrate. In 384. We'll be working on this 1.55 microns in 1550 nm. So now this is set. And
Sir, can I ask one question?
yeah, sure.
Can you open that window again? System parameters.
Yeah, sure. This one. You can take you can take a screenshot of this. I think this will be beneficial for you for your further projects. I can share the paper of IEEE also, so that can be a reference. Is that fine?
No, sir, I'm not able to see this.
I think the slides are not visible.
Okay, okay, just a minute. Just
Yeah.
visible now?
Yes, yes.
Just a minute.
And now open the Opti system window, I think.
Okay, this is the global parameters we have used. So you are requested to have a screenshot of this. And then we shall be moving to.
Sir.
Hello. Yeah, can you please repeat? now I am moving to the software portion. Okay, so this is all set up. Now we are using pseudo random bits. Then pulse generator RZ.
ठीक है ठीक है आपका हो गया है इसको भी ध्यान रखो है हाँ देखिए कितना से शुरू हुआ आपका हाँ ये बिल्कुल हाँ हो गया क्या आपका कौन सा प्रॉब्लम है ओके क्या है इसका आंसर ठीक है कैसे कंप्लीट किया बताएं हम्म ठीक है रितिका अभी बाकी लोग जो रहे हैं उनको थोड़ा सा 10 मिनट के वेट करने की बोल रहा 3 बजे से स्टार्ट करेंगे मेरा लैपटॉप बैटरी होगी कि नहीं भाई आगे नहीं होगा हाँ तो हाँ मैं कुछ जल्दी मार रहा हूँ लास्ट वन क्या नवीन केशव नवीन बताइए क्या है अरे अपना माइक ऑन करो हाँ तो कौन सा प्रॉब्लम है एक्चुअली ऑर्डर ठीक है हम्म हम्म ठीक है नो अभी बाकी लोग दूसरा लोग बोल ठीक है सबका अंदर जो भाई कैसे की बताओ प्रोसेस बताओ अरे दूसरा स्टेप पे तुम लोग कहानी पढ़ रहे हो क्या स्टेप ये बताओ अरे पांचवें सेक्शन लिखेंगे स्टेप बाय स्टेप बता देना क्या चाहिए 15 मिनट छोड़ दो 15 मिनट हाँ हाँ ठीक है ठीक है। ये बताओ कि आप इनवर्स Z ट्रांसफॉर्म निकाल रहे हो और जिसकी आपको आगे दिया था कैसे निकालें?
Now we will be taking care of the parameters. So as per the paper,
ठीक है ठीक है बोल देना बाकी लोग से कि वो हमें पता है 250 ठीक है ठीक है आप लोग जा सकते हैं ये हम नहीं है
Gaussian
चलो
0.5. Rise time will be
देखो दे जा रहा हूँ सर जा रहे भाई
क्या सर?
फिर जाता हूँ कैसे करूँ
ये आ जाएगा कि देखो
ये आ रहा ये कैसे कर रहे
line width we will be using is 0. Now for the optical fiber, length will be 50 kilometers. Attenuation linear losses 0.2 dB per kilometer. That's okay. And for this, ten dB. Noise figure this is dispersion compensation.
रूम पर आई थी अभी हूँ
I request everyone to mute their mic. So this will be changed to 10. This is basically a dispersion compensation by fiber. And the linear losses means this attenuation 5, 0.5. this. We will set it to. So for the number of loops, with 10, and for this we shall be increasing the bandwidth. So basically our main motive here is to see how we can conclude the results with RZ for 40 Gbps transmission, and afterwards NRZ. Let us move back to the slides. So this is the layout for our first portion. This is what we have generated using RZ scheme for 40 Gbps. Whereas if we talk about NRZ layout, so instead of the loops to 10, we are setting it for 5. So it will not go beyond 250 kilometers. In that case, if we simulate this, this will be stimulated with the power of 1.25 milliwatt, whereas in the earlier one we are using the power 4 milliwatt. That is approximate value. Distances greater than 250 kilometers, maximum Q factor becomes smaller than 6. Therefore, this is the maximum Q available distance with the performance. Comparing the positions of maximum of the two curves, we can clearly see the shift towards the greater input powers and with the duty cycle 0.5. So these are some of the conclusions we can undertake during the simulations. So what is good, what is not good, what Q factor is good for this range. Now, there are two different situations. We can consider that is self-phase modulation, and it is assumed as 0. We are not taking it into account for the simulations. The noise figure is also not taken into account. So these parameters or these figures also affects the transmission system. So these should also be taken care for this. So at lower power levels, the performance is mainly hampered by the accumulated amplifier noise. At high input power levels, the transmission distance is significantly reduced due to the self-phase modulation. Now, if we talk about pre-version means I do hope those who are using Opti system, they must have gone through such type of simulations where the pre and post simulations are being analyzed. Means when the dispersion compensation fiber is shifted before the actual fiber for the transmission purpose. So that is known as precondition. When dispersion compensation fiber is used after the main optical fiber or SMF, so that is a post condition. So for the equivalent process, there are some of the layouts available in the sample files. Those who have installed, they can go through the dispersion compensation folder. In that, they can find pre, post, and symmetrical analysis for this dispersion in a fiber. And that is also a part of a paper. So you can go through that and you can easily understand how you can achieve different Q factors using such kind of analysis. So in that case, two dispersion compensation schemes are studied, and in this we will be studying the this pre-compensation. So that will show you these kind of results, means the Q factor and the BER analysis. So in that case, the result indicates the post-compensation scheme is superior compared to the pre-compensation scheme in dispersion compensated systems. So once you go through the layouts of RZ, then NRZ, and apart from that, this pre-compensation layout of RZ. So when you compare three of them, so you can understand which is superior. So after these studies and calculations, so this indicates us that the post-compensation scheme is superior compared to the pre-compensation scheme. So for that, the conclusion, dispersion compensation is necessary. RZ modulation is superior as compared to the conventional RZ modulation format. At low power levels, the performance is mainly hampered by the accumulated amplifications. At higher input power, the transmission distance is significantly reduced by non-linear self-phase modulation. Post-compensation scheme is superior compared to the pre-compensation scheme. So as per these references, this phenomena has been simulated. Apart from this, we can also share the paper. Let me move to that one. So this is the paper of IEEE Photonics Technology Letters, Volume 9, Number 3, March 1997. Comparison of NRZ and RZ modulation format for 40 GB per second TDM time division multiplexing standard fiber system. So in this case, they have used the range or the distance, you can say 1200 kilometers and 400 kilometers. The phenomena is same, whereas in this, the non-return to zero and return to zero signal transmission in dispersion managed high-speed time division multiplexed system operating at 1.55 microns over the already installed standard fiber network are compared by numerical simulations. It is shown that for upgrading the existing network to 40 GB per second, the RZ modulation format is superior compared to conventional NRZ modulation. Standard fiber transmission distance of about 1200 kilometers and 400 kilometers are shown to be feasible within the RZ and NRZ formats. So in that case, if you go through the fiber parameters, so these are the fiber parameters. So our calculation is also somewhat similar to these parameters. 50 kilometers of SMF, dispersion compensation 10 kilometers, and their particular dispersion of fibers in picoseconds are 16 and 18. Apart from that, they are concluding that the potential of NRZ and RZ signal transmission for the future dispersion managed 40 GB per second TDM systems based on the already installed standard fiber network at 1.55 microns has been analyzed by numerical simulations. In particular, we showed that for 40 GB per second TDM systems, the RZ modulation format with a duty cycle of 0.5 is superior to the conventional RZ modulation schemes. A standard fiber transmission distance of approximately 1200 kilometers at a maximum fiber input power of 6 dBm was shown to be feasible. Assuming the conventional NRZ modulation, the standard fiber length is limited to approximately 400 kilometers. So there we have used 250 kilometers instead of 500 kilometers as compared to RZ. So this is 400 kilometers at a maximum fiber input power of 1 dB. This result in a threefold increase in transmission distance for the RZ signal format compared to the conventional NRZ format. Furthermore, we showed that in 40 GB per second dispersion managed system, the system performance does not depend upon the particular spacing or positioning of the dispersion compensating fibers. So here it should be noted that the system performance will be degraded by polarization mode dispersion, which was excluded in the numerical study. So as comparing to this, we have the layouts, and now again moving to our software part. So in that case, this is for RZ, and similarly, if I go for NRZ, so this is for NRZ. Here the power is 1.25 milliwatt. Again, we are using this optical fiber, 50 kilometers of length, the same amplifier, then dispersion compensating fiber, then again amplifier, loop control of 5, then the same phenomena. And after the simulation, the Q factor will be higher because the distance we are using here is only 250. So this is the Q factor. For further comparisons, you can check out this report format. You can drag and drop the various calculations here. So in that case, but we have not used any iteration here. So it's best if you can go through this, or just a minute. For comparison between two layouts, what you can do is, for example, this is for RZ. So for RZ, the window for RZ, and same place for layout 2. This is for NRZ. So now in a single pane, we have RZ as well as NRZ. And when I simulate it, so this is just for a purpose of comparison of results. Or else if you have separate projects for separate layouts, what you can do is you can extract the curve of each analyzer or visualizer. Then you can export the data to Excel file, and from there you can make a graph for the comparison purpose. Okay, this is simulated. So if we go to this project browser,
Hello, sir.
yes.
So whenever I click on the project browser, it coming disabled.
You must be using a cracked version then. That is,
Okay, sir.
could you tell me the version you are using, OptiSystem?
So it's
Hello.
version don't remember the version 5 to 6 years
Okay,
back.
that must be a 7 version, and that is a
It's a
cracked
7.
version. Okay, so I recommend you to download that from OptiWave website. At least for 30 days, you can evaluate it. Right? Okay. Any other question? Anyone? Any doubt up to this part? Okay, fine. So I was talking about the results and their comparison. So Q factor, then again. So it is up to us how we want to compare it. Apart from that, if I talk about minimum log of BER and minimum log of BER, I don't know, I guess. Okay. Minimum BER and this minimum BER. This is
Sir, I have one question.
yeah, please. Yes. Your voice is breaking in between. Hello.
Hello, sir, can you hear me?
Yeah, I can hear you, but in between your
Yes,
voice
sir.
is
Hello.
yeah, yeah. Mr. Rajat,
Hello.
I think it's not you. Hello.
Yeah. Hello.
It's best if you can write your query in the
Okay.
chat box.
Okay. Okay. Okay, sir.
Yeah.
Okay, sir.
Okay. Please,
Yeah.
please.
Sir, I have a one question. Can I ask?
Yeah, please.
Sir, in photo detector, one of the parameter of photo detector is dark current.
One of the parameter.
Dark current. First one, dark current. So in
Yeah.
some paper, the value of the dark current is 10 nanoampere, and somewhere it is a 1 nanoampere. So what is the
Actually, ma'am,
significance of?
I think this is a residual electric current means. This is a like ever the left behind is residual electric current. So the by default value right now for the latest versions we are using is 10.
10 nanoampere.
Yeah.
Oh, yes, sir. And sir, one more question is regarding that system parameter. Can you open that window?
This one.
This one. So here we have taken that bitrate 40 Gbps and the symbol rate 10 Gbps.
Bitrate.
40
Okay.
Gbps and symbol rate 10 Gbps. So can we take like this or we have to take both the same value?
You can take like this. This is okay. You can put it like this.
So can we take 40 Gbps bitrate and the symbol rate is also 40 Gbps?
You can. It's up to the result calculation. So if you can also give it a sweep in case you want to provide by scripting method. So in
That's
case
fine, sir. My question is only that can we take both the values same or we have to take like that 40 and 10? So is there
if you
relation between the two or we can take it like this?
it should be the symbol rate should be different from the bit rate.
Or it should not be the same.
It should not be the same.
And same thing for that
Or
sequence.
sorry.
Yes, sir. Carry on.
What are you telling, sir?
Same thing, sequence length and sample per bit. Here we have taken a 128. Both are same.
Yeah.
So if we take a sequence length 128 and sample per bit 64, so it has some meaning or we can say set both are same.
You can use that. You can use sample per bit rate 64 also.
64. What is the difference between that if we use same or if we use a different? Actually, I have confused with these 4 parameters, sir. Randomly, I put something found from the paper and getting something. So I would like to know about.
I can understand. It's your
That is my big question,
4
sir.
months. It's your 4 months old query. I can understand.
But still, I have that query, sir. What should we have to do exactly with that 4 parameters?
See, first of all, understand the concept of this simulation platform. In this platform, whatever the dialog box you are like seeing this for setting up the global parameters. So until or unless you set up the by default global parameters, your components in this will not get simulated. You will not get the result. If your bitrate is very high, then the result will be negligible, right? But if your bitrate is low, means say if it is 5 Gbps, for example, then the result categorized in this format means within this limit can be visualized. Means your visualizers and your mathematical calculation will work, right? But for like a safe side, we have defined the global parameters in a generic part. For example, I click this, so you can see
Here
bitrate.
they have taken a same bitrate and a symbol.
No, this is generic. You can change as well, but for the low calculation means for lowest values. If you want to use this, it may give you a result, it may not. But in case you go a little bit down for these parameters, you may get the result.
Same thing with sequence length and sample per bit also. Sir.
Exactly. But you should be careful regarding the setting up of pulse generation components, or you can say, just a minute. So in case we have this one, for example, when you set a bitrate for something and you set it for a script, its bitrate means this is scripted and it will take the similar value but you set it for the layout, right? So for such kind of components, this is one of the example. For such kind of components, you should be careful regarding setting up the parameters. Moving further,
Can you hear me, sir?
yeah, please.
Compare the two as you have did NRZ and RZ. So in that case, we have to use two layouts on the same page and simulate simultaneously. So finally, we get in the result the comparative study only, even it is a eye diagram or even we are comparing BR. So it is a kind of comparative study we will get if we if we paste layout 1 and layout 2 as RZ as you did in RZ and NRZ, right?
Exactly. So actually,
And
this
if
implementation.
separately we do, we won't get the result, sir. Separately we
No,
do like
you can do it separately, but in that case, how you can export this type of
okay,
parameter
okay,
in the window?
okay, sir, okay, sir, okay, sir.
Yeah, they are
Also,
also
also, sir, regarding global parameters, you said for high data rates we have to set global parameters, right? If
yeah,
for low data rates it will be not an issue, but if we are working for more than 40 Gbps or like simulation parameters, then we
yeah,
have to set the global parameters, right, sir?
exactly.
Okay, sir.
According to your bitrate, sequence length,
Yeah,
samples
yeah,
per rate, your number of samples will be set automatically.
okay, okay, sir. Okay.
Yeah. Okay. Anybody? Any other query? Okay. So in this paper or in this modulation of setting up or implementing this 40 Gbps for an existing laid fiber. So in that case, we are studying the phenomena, which one is the best. And for that case, you need to compare the results of RZ as well as NRZ. And apart from this, another simulation. Let me show you the third one, pre. So this is a pre. So the difference here is so the dispersion compensation fiber is set pre of actual fiber. You can change the name of optical fiber as DCF. You can change it here. So this is just for a presentation format. So if I simulate this, this is the Q factor I'm getting here. This is the eye diagram. So with the same phenomena, in that layout, you can add Another one. Now I'm again simulating all the layouts in the single project window. Phenomena will reduce the time for getting the result. Now we have NRZ, pre-RZ, as well as this RZ. So comparing the results of various features of this BER, or in case you want any addition into this, because after this publication from Mr. Brewer, so in this next year in 1998 they came up with another idea of comparing the fibers with TDM modulations of 40 Gbps and beyond. So they keep on increasing the bandwidth for the simulations and for this 40 Gbps and more data. So similarly, if you have anything in your mind, you can add it in this. You can compare the spectrums of these particular fibers. For example, if I see the spectrum here and if I see that here, no, this will be okay. So after modulation and after passing through the fiber, or you can say at this part, what will be the effect? Please make a note of this. Like this setup is for existing fiber, the existing working fiber. So that is also a part for cost effectiveness. So this is the noise which is also included in this. This is our sample signal. So that is the difference. Whereas at 1.55 microns, we have our spectrum at a proper location. This is the one. So similarly, you can compare other type of results or simulations. So anybody, any question related to this or any topic for Opti system or any application, anything?
Sir, and for a VLC link, any reference for this particular VLC link design in OptiSystem?
A reference paper.
Where I can start with the designing part in OptiSystem for optical wireless VLC link.
Just a minute. We may have.
I can mail you also if you can revert on that mail also.
Okay, in this case, we have a type of this or on-off shift key related to this. in regarding VLC, what actually you require? Want a topic or okay, whatever you write and email.
Yeah.
Is
Yes,
better.
I will email you, sir. Okay.
Yeah, sure, sir. Sure. Okay, the audience is asking for email ID. So this is and ready? Any question? Yeah, Dr. Amit.
Yes.
Ask the audience if they have any question, or else I
Yes,
think
participants, if you have questions, then you can ask. I think they are asking in meanwhile. So right now they may not have more queries.
okay. So from my part, this is over regarding this topic 40 Gbps implementation.
Okay, so I think we may stop here. If there is no question from the participants, we are hoping that
Actually,
we'll have some more questions.
yesterday they were coming up with a lot of queries, but
So
I
that's
think
why
today
that's why we left some more time for the question and answers, right? But
exactly. I have speeded up everything today with the speed.
okay.
Yeah.
Yeah,
If
no
anybody is
problem. It's
interested,
fine.
yeah, I have provided my email ID. So if anybody want to interact with me, they can email me directly.
Yeah, definitely, yes.
Yeah.
Okay, so thank you all the participants for joining us again, and now you are requested to join us tomorrow morning. Okay, so thank you all. Have a nice day. Yes.
Thank you so much. Thank you,
Yes,
audience.
thank you,
Thank you, Triple
Amandip,
IT
for
Google.
sharing your valuable time and spending 2 sessions with us. So thank you, Mr.
Same
Amandip,
here.
again. Yes.
Thank you. Okay, thank you.
Yes. Thank you.